Hey guys, Assalamualaikum and good afternoon. So, how you guys been doing? Are you guys busy? Because I think this is already week 11, right? So how's the progress of your study? So far, so good or not good?
Good, good, doctor.
Most of them.
Most of them good.
Some of so far so good, some of bad. Ada dua-dua.
Alright. So it should be balanced. Some good, some not good. So it's gonna be balanced. Alright, guys. So, what about the test? How do you guys find the test? Because there are some of you guys didn't submit. I mean, like some of you didn't submit question one, some of you didn't submit question two. What happened?
Not enough time.
You got to be kidding me! Not enough time. I thought some of you also some of you already fall asleep while taking the test.
The last test, so that we have two session, right? That
Yeah.
tupak, ada satu tupak. Oh, right. I don't know why they didn't submit.
Why? Okay. I know. I think it's pretty hard, to conduct this course online because didn't can't really access how your understanding is. Cannot see even your face, expression while taking the test. So it's kind of hard for us to, know how far that you guys understood the course. Yeah. So because we have already marked test one, but I think the result is not that good because I think the question is pretty straightforward. Everything is direct from the lecture note. It's just a matter of you guys go through your lecture note or not. So I think if you guys go through your lecture note, I mean, you should be able at least get almost two-thirds of the marks. But if you guys are not putting any effort, so I think that's why a lot of you guys are missing a lot of marks in test one. Right, but yeah, I think it's still okay, but you guys still have time because as you guys see on my sharing screen right now, so this is the breakage of your coursework marks, right? So, all right, so this is how we're gonna divide your marks for this subject. So assignment one that will be due on Sunday, it consists of 15 marks. So I'm going to be releasing assignment two maybe by next week. And then lab, which you guys already completed 10%, and the MTE is just the test that you took is just 10%. And then we have another 15% for your mini project, which is done by you guys in a group. And then yeah, this one consists a lot of marks, so open book test, which I'll be doing it uh, on week 14 because week 13 we're gonna do the presentation for your mini project. Right, so it's gonna be presentation for your mini project and also submission of the report. So open book test will be done on week 14. Right, so I think you still have a lot of marks that you can get from the assessment. So hopefully that you guys are really putting an effort into the task that I'm going to give to you guys. So like the assignment one, I think some of you are having problem doing it, but I think in maybe after I covered the lecture material for today, I'll be sharing with you guys maybe some, not sharing, just do some recap to give you guys idea how you can do your assignment one. Alright, so before I proceed with the class, do you guys have any question on the assessment marks?
No, doctor.
Doctor,
Yeah,
how many quizzes that we have?
only one,
Uh,
which will be next week too on Friday class.
okay, okay, thank you.
Alright, we will share any marks or we will know at the end. Yeah, I'm gonna share the marks, but not the 100% marks, right? So maybe I'm gonna share around 60% of the total marks with you guys, so that you guys know the idea how far that you guys have been doing in this subject. All right. Any more question? Open book test will be application test. So it's not like direct from the textbook. Right. So this cover, yeah, the cover the whole knowledge that you guys, I mean the core knowledge that you should have from this subject. Right. Any more question on this assessment?
No, doctor.
Okay. All right. So okay, if no, then I'll proceed with the content first. Yeah. Then we'll go into your the recap for your assignment one. Okay. All right, guys. So pay attention to this lecture. By the way, I'm recording this lecture. I'm gonna upload it. So this lecture is pretty important for you guys because this one will be assessed in, I think, a few assessment later. So hopefully you guys can understand this subject very well. Right. Okay. So we're going to cover about memory, right? So have you guys learned about memory before in any other subject before? Memory, RAM, ROM, volatile, non-volatile. Have you guys heard of it? Yes. Which subject
Yes,
is it?
sir. Yes,
Which subject?
in diploma.
Oh, okay. All right. Okay. Okay.
Mm.
For those of you guys in diploma, yeah. Of course, you guys should have heard it. Yeah. But okay, self-study. Okay. Okay. So yeah, some of you, I'm pretty sure you guys never heard of it because I think this is the first subject that you guys gonna learn in details about it. ICT in SPM. Okay, that's good. All right, so okay, we're gonna cover about some of the memory basics, memory definitions, organization, and also static RAM. All right. Okay. So basically, by definition, memory is a collection of cells capable of storing binary information. All right. So memory by definition is just a cell. So I mean, like, if you guys want to imagine how memory is, right? So just imagine a box, right? So a box which have a lot of partition in it, right? Okay. So let's say, I mean, this is considered as one cell. One cell. So one cell can store one bit of data. So when I say one bit of data, in computer it can be either one or zero, right? So this is binary, right? So one cell can store one bit of data. So imagine a box can store 1, 2, 3, 4, 5, 6. So that means this memory can store 6 bits of data, right? So it can be whatever value. It can be 0, 1, 1, 0, 1, 1, right? So it contains electronic circuits for storing and retrieve information. So how do they store this information? Either one way or the other. Either they are using either transistor, or it can use capacitor, right? Remember you learned capacitor. Capacitor is the electronic device where you can use to store charge, right? The capacitor things, so you can store charge in here. So this is one of the way how they can construct a circuit to store data. And then it used to provide temporary or permanent storage capability, right? So basically, when we talk about memory, right? So there are two type of memory. The first one is temporary memory. When we say temporary memory, we mean it by volatile. So if you guys heard when people say volatile memory, that means when you take the power off, then all the things in the memory will be wiped off. So, example of this volatile memory. Volatile memory example is your RAM. All right. So imagine your RAM in your computer. All right. So that is the closest memory apart from cache. Right. So there is cache. All right. In this one, you will learn the detail in computer architecture. All right. So this is your CPU, your processor. All right. So inside your processor there is memory where they call it as cache. So this is inside the silicon. So inside the chip of the processor itself, they have cache. But they cannot put too much memory here, so they bring out the memory. So the closest one to the CPU is your main memory, right, or your RAM. So this is where you're gonna store a lot of things that need to be processed by CPU. That's why if you guys, let's say for an example, your laptop, right? So if you guys are having problem with your laptop, for an example, there are a lot of delays when you try to open application or when you try to do a lot of multitasking stuff, right? So if they are stuck or delay, right? So the first thing that you have to look into is your main memory. So for example, you are using 4 gig, right, of main memory. So this is just enough. You want to do basic things. So for example, if you upgrade to 8 gigabyte of so 8 gigabyte, right? So that means which means that this main memory can store 8 gigabyte. So 8 times giga, right? So giga is 1 to the power of what? Giga is 1 million, right? So times 1 million times by byte. Byte is 8. 1 byte equal to 8 bits. So this is the total number of bits that you can store here. So by expanding your main memory from 4 to 8, you have extra space for your computer to store the stuff to be processed by the processor. All right. So that means by memory. But this memory is volatile. When you take off the power, then there will be nothing stored in the main memory. Okay, and then there's another thing where you store your permanent stuff. This is your hard disk, right? Hard disk. But nowadays, I mean, they have the latest memory, the non-volatile memory, where they call it as SSD, right? So SSD, I mean, this hard disk is using the disk, right? So there are a lot of disks inside the hard disk. So that's why, I mean, if you guys are using hard disk memory, you're gonna hear the noisy sound because the rotation, right? The disk is rotating when they want to access the data. But nowadays they are using SSD. So SSD is almost similar architecture with main memory. It is using silicon, right? So it's using chip, so you won't hear the rotating noise again, right? So it is faster, but it is quite expensive compared to hard disk, right? So this is non-volatile. So what is non-volatile? When you take the power off from the computer, your data will still be there, right? That means by non-volatile. Volatile, when you take the power off, all the data will be gone. All right, so why is memory so important? Okay, memory is so important because there are too many things to be processed by the processor. When there are too many things to be processed by the processor, so you need to have a place, to store the things, right? Temporary. Right? While waiting for their turn to be processed, they have to wait somewhere. So that is the place where they're gonna sit before they meet with the processor. Right. So example, the data from your printer, mouse, keyboard, monitor, digital camera, all the things that be connected. Now all this data will communicate through memory. Right. So it will take turns to be processed by the processor. So that's why nowadays, they go into multi-core, right? So previously they only have one core, which means that only one machine to process. So now they break it out into multi-core, so they can have a multiple data going inside and be processed at one time, right? So that is what they call it. Multi. This is almost the basic things that you need to know before you go into the computer architecture. All right. So what else? So the data, then memory process. Okay. All right. So that's memory basic. If you guys have any question, please let me know. All right. Okay. So here's the types of memory. So there's a RAM and there's a ROM. Okay. All right. So basically there's a RAM. So this is random access memory where you can continuously access the memory, and there's also read-only memory. Alright, so okay, RAM is your main memory, right? So this is your main memory, the one that you can upgrade in your what do you call it, in your PC, in your laptop, right? So and then you can write on it and you can read, right? So you can do both. But there's another one, ROM, right? So ROM is a read-only memory, so you cannot write on it. So where does this thing being used? So normally it's being used to store the BIOS. Anybody know what is BIOS? Anybody guys? No?
Operation
BIOS?
behind the system.
Operation behind the system. Not
Macam nak
really.
cakap macam motherboard punya
Motherboard
system.
punya. Okay, motherboard punya system. Is it the same with operating system, Windows?
No, it's not. Because I have some experience about BIOS.
Okay. Yeah, BIOS is a system for booting lah. So basically, if you don't have any OS in your PC or in your laptop, let's say you don't have Windows, you don't have Linux, right? You don't have Mac OS, you don't have anything. You still can boot your PC. So it will enter one OS, right? But a basic OS. So that is your BIOS. Of course, there is a basic input-output system, right? So that's the terminology. But what it does is that is the basic system that control all the settings of your motherboard, or the memory. So most of the settings that you can do, the critical settings. For example, if you want to do overclocking, right? So the settings that you need to change in the BIOS. Right, then after that you install the OS, which can help you or assist you guys to do more things in using your PC. Right. Okay, so normally BIOS, they will use ROM, right? Because they don't want you guys to mess out with the BIOS. Because if anything happen to BIOS, then you cannot start your PC. This is one of the important software in your PC. All right, so memory data elements. All right, so typical data elements are bit. So this means a single binary digit. So and then there's also term they use byte, right? So normally they use byte lah. So if you guys listen to the size of the memory, so they say 8 GB. Right? They don't say 8 GB, but for the network speed, they spell it in terms of bit. Right, 4 gigabit, 8 gigabit, but in terms of memory size, normally they use byte, 8 gigabyte, 16 gigabyte. What's the size of your hard disk? 1 terabyte, right? Example. So they use byte. So 1 byte consists of 8 bit of data. Okay, but you will also hear the term word, right? So this is kind of tricky, So the terms word has no, like universal standard. Like byte is standard. Everywhere you go, the size is 8 bit. But word is depend on the type of the processor. So you need to check the details. So let's say you want to know the size of the memory of a system in terms of word. So you have to check the data sheet, the document. So let's say, for example, Intel 8085 processor. So you have to go and check. So if one word of data means 1 byte or 2 bytes or 4 bytes or 8 bytes, right? So this is something that custom or tailored to the brand or to the design of the processor itself. Okay, memory data, a bit or collection of bits. Okay, memory operation of memory data supported by the read. Okay, alright, okay. Memory organization. Okay, this is want to show you guys how different processor they use a different setting. For an example, right? So this Digital Equipment Corporation PDP-8. So this is one of the earliest processor that being produced in the industry. So they are using a 12-bit address to address 4096 of bits words. Right. So if you guys want to understand more, okay, let's get the calculator here. All right. So 12-bit words. Okay. 12-bit words to address 4096. All right. So let's say 4096. Right. 4096. So in binary, it has to be represented by 4, 8, 12 bits, right? 4, 8, and 12 bits of data. Because if you go from 0 to 4095, it will be 1111111, right? So let's try here. 4095. Right, so it be 111. So you need to have 12-bit address, to represent 4095 location, from 0 to 4095 location, which means you need to have a 12-bit, right? So 4, 8, 12, 12 bits. So starting from the whole 0 until the whole 1, right? So 000000000 until 1111111. So that is how we want to understand this information. But then, so they have 4096 location. So imagine, this is the memory, right? So this is a memory. So they have a lot of location here. So this is the address. So it's starting from 0 until the last location is 4095. I start from 0. So the last here is 4095. So that's why they need to use 12 bits of data to represent the location, so there will be 12 bits of data, right? So until 1111. So again, here is 12 bit. All right, so just imagine, so they have 4096 location, including the 0. So they need to represent it by using 12 bit of address. And then here, 12 bit words. So in this location here, they can store 12 bit of data. Right, so that means for this processor, when they say one word, so they mean 12 bit. Right, so okay, that's how we use the word. Okay, then IBM. So IBM use 24-bit address to address 16,700 of 8-bit data, or 4 million of 32 words. So you can do the same thing again to check how it being done, right? So, but in IBM 360, when they mention one word of data, so that means the size is 32-bit. You see, it's different between different manufacturer. So then Intel 8080, so for 8-bit predecessors, so they use 16-bit of address to address 65,000 location of 8-bit data, which means 1 byte of data. All right. If you guys have any question or confusion, please let me know. Okay, this is the basic of memory block diagram. So imagine this is your memory, and then here is your n bit of data input lines. So it's depend on your design. So let's say we take Intel, right? So Intel, for example, if they say 8 bit, right? So 8 bit of data. So here the input line is 8 bit. But if the what do you call it, the you are using IBM, uh, so here IBM is using 32 bit. All right, so this is really depend on your design. Again, you need to have the address line, and then you need to have the read input and also write. So if you want to read from the memory, so you just give high to read. Or if you want to write to the memory, then you just give one to the memory, right? So whenever you send one read to the main memory, and then it will output the data. So which data they will pick? So they will pick based on the address line, right? All right. So okay. All right. So this is another example. So memory organization. So example of memory. So address bits is 3 bit, and then there's the M, which is where is the M? Yeah, M is the address bit. So the address bit is 3, and then the data bit is 8. Uh, so therefore, the number of address line here is 2 to the power of 1, which is the M, is equal to 8. So in this case, 2 to the power of 3 is equal to 8. So that's why the address bit size will be 3 bits. So you see here 3 bit to represent all the location of the memory. Right, so they have 8 location, so they need to use 3 bits of data address input. Sorry. So address range 0 to M. Okay, right. This is just explanation. Alright, so this is another example. The address bit is equal to 10 bits. So here, I mean, by looking at the diagram here, right? So we can translate the information. For example, looking at the address here, so the address you can count how many bits here. So you count it, then you found out the address bit is equal to 10 bits. Right, then the memory contents, you look at the memory content, look at the size. Then you know, I mean, by counting it, then you know the size is 16 bits. Right, then the address line, so I mean how many address you can cover. So you know the M, right? So you just do the 2 to the power of 10. And you do 2 to the power of 10, you will get 1, 0, 2, 4, right? So here you get from 0 to 1, 0, 3, including 0. So in this case, the memory has 1K words of 16-bit data. So 1K words of 16-bit data, which which also equivalent to, so this is one word. So the whole thing here 16-bit. So this is one word, right? Which is also equal to 2 bytes, right? Because it's 16 bits, right? So the memory has 1K. Right? So this one is exact. The exact number is 1024, right? But here the representation is 1K. So you have 1K of 16-bit memory. Right, so this is the total number that you can have, right? So let's say you get the calculator here. So you just get 1024 1024 times by 16. Right, so this is the total bit number. So 16K bits. Right, so this 16K bits you can store in the memory. Alright, so yeah, this is K, kilo to the power of 10 is K, to the power of 20 is mega, to the power of 30 is giga. Alright, so this is something that you can think of. Alright, memory operation. Okay, so I mean there's a process that you need to use, to read and to write. To read from the memory or to write into the memory. When you want to read the memory, so the operation that you need to do, so the first thing is to place a valid address on the address line. So let's say this is your memory, right? So the first one is the address. The address. So the address can be any bit. So let's say the size is M, right? To the power of M. So you have to have the address first. Then activate the read. So you have to send the one signal to the read input, right? Then it will output the data. So it will output the data. So here is the data out. So that's the procedure for the read memory. But for write memory, again the same. So which memory location that you want to write, but then you have to activate the write input signal. So the write input signal, and then activate the write, and then apply the data. So there's an input data. So it's a data input, data in. So the size of data in should be the same as data out. For let's say it is 8 bit, and then both will be 8 bits. Right, so that's the process for read memory and also write memory. Right, so this is the same. Chip select. So we're going to talk about chip select, right? So when we design the memories, so normally they have a standard size of memory. So let's say you want to design certain size of memory, then you need to sometimes use multiple chip, right? So that's why they have here the chip select. So for you to choose which chip that you want to access the memory. Later we'll look into the example. Right, so this is another example of volatile and non-volatile. So random access. So this is the type of RAM, right? So they have static and also dynamic. So static they use transistor, dynamic they use capacitor. But if you compare both, right? Normally static is better, SRAM, right? So but most of them use DRAM because the circuit is simple. But the thing is that you have to refresh because when you are using the capacitor, right? So there's the charge in here, I mean, it will not be remain, right? So it will be reduced by time. So that's why you need to have a refresh charge circuit to refresh the data in the capacitor. Right, so that's RAM. So they have SRAM and also DRAM. So SRAM design is quite complex and consists taking more space compared to DRAM. So that's why mostly cache design they will use SRAM, but for the DRAM normally being used in the main memory, right? So this is for the normally main memory or random access memory, which is volatile. And then also the example of volatile memory is the FPGA, the one that we should use in this course, but we are not able to because of the COVID situation. So FPGA has a volatile memory. If you take the power off, then the whole circuit that you have loaded on the board will be gone because it is volatile. There's also a type of chip, kind of FPGA family too, but they call it as CPLD. So this is non-volatile. So non-volatile means that one, you load the code inside the board, right? So this is the board, the CPLD board. So once you load the code in the CPLD board, so the code will remain here. So when you take the power off, then you power on again, then the circuit will still be there, but not for FPGA. Alright, okay, so cell arrays. Okay, let's look into example here. Okay, guys, so far so good. Any question?
No, Doctor.
Okay, alright. Okay, this is one example, right? So here, they are using four. Okay, okay. Look at the big box here. One. Oops. Two. Right. So 1, 2, 3, and 4 box. So one box here consists of 4 cells. So they are using 4 box of 4 cells memory. So one box here contain 4 cells. Right. So here in this case they are constructing 16 times 1 RAM chip. So that means at one time they can store and read 1 bit of data. Right, so how you can construct this kind of memory? This is just for example, right? But I think no processor will use this kind of memory because it's only 1 bit, right? So you can store only either 1 or 0. So how you can design the data? Okay, so by looking at the front number here, you find the 2 to the power of what equal to the number there. So in this case, 2 to the power of 4 is equal to 16, which is equal to 4 bit. So from here, we know the address that we need to use to design this kind of memory, 16 times 1, need to use 4 bit of address, which means it start from A0 until A3. Alright, so how we do this? So A0, A1 will represent the what they call here, column. Alright, so A0 and A1 will represent the column. So you can see here column decoder. And A2 and A3 will represent row decoder. Right, so remember at one time we can only read or write to only one cell. Alright, so in this case, okay, let's say, where's the example? Okay, let's say here, the example. Alright, so if address is 1001, okay, so they give here 1001. Okay, we know that here is A0 and here is A3, right? So A0 is 1, A1 is equal to 0, and then A3 is equal to 1, A2 is equal to 0. Alright, so by having A1, A0 equal to 0, 1, so it will choose, okay, so there are 4 here, right? So 0, 1. So here is 0 and here is 1. So because here is 0, 1, right? 0, 1, so that means it is equal to 1. So it is selecting this column. Alright, so and then we go into A3 and A2, 1, 0. So 1, 0 is equal to 0, 0, 0, 1, 1, 0. So column here. Sorry, row number 2. Right, so we look at the intersection. So the RAM cell that being selected by having address 1001 is RAM cell number 9. Right, so this is just one example. Alright, so this is another example. Okay, now still same. We are using 4 times 4, which is 4 box, which have 4 cells. 4 times 4 RAM cell. But now we going to create 8, right? 8 times 2. That means at one time we can read and write to 2 bits of memory. Okay, so again, how we want to design the address. So look at the number at the front here. So just find 2 to the power of what equal to 8. So in this case, we got 3. All right, so 3. Then what we do here, so one bit, the last bit will go for the column decoder, right? So A0, so we have 3 bit, A0 until A2. So A0 will go to the column decoder, A1 and A2 will be going to row decoder, right? So you see here. So since okay, right, okay, example here. So if address is equal to 011, okay, right? So here A0 is 1, and then A1 is equal to 1 and A2 is equal to 0. Right, so okay, when it is equal to 1, then you will choose here. We'll choose both here, both column, alright, because now we are doing for 2-bit reading or writing at a time. So 010001. So that means it's choosing row number 1. Right, so that means it is selecting cell 6 and 7. Alright. Okay. Alright. So let's say we want to construct a bigger RAM, right? So in this case, it is 32K times by 8 bits. Alright. So step by step, how we going to do this, right? So the first one, we are looking into the first number here. Right, 32K. Right, 32K is also in memory, right? In memory, when they say 32K, it is actually equal to 32 times 2 to the power of 10, which is equal to 1024. Right? Okay. Right, 32. Okay, now we already take out the 2 to the power of 10. Okay, now we find out, I mean, what is 2 to the power of what equal to 32. Then you do the math, then you get it is equal to 5, right? 2 to the power of 5 will be equal to 32. Right, so then we know that how many bits that we need to use to construct this RAM for the address. So it is 16 bits, 10 plus 5. Right, and then the data bit is equal to 8 bit. All right, so okay, now how we going to know? I mean, like how many bits that we need to use for row decoder and how many bits that we need to use for the column decoder. Right, I guess so. What you need to do is that you have to do the calculation here, right? So 32K, you have to get the number, the total number of bits, right? So 32 times, you can do it, right? Right now by using your calculator, times 1024 times by 8. So the exact number that you need to get is equal to 262144. And then here, by getting this number, you do the square root, right? You do the square root, then you will get 512. Then you find 2 to the power of what equal to 512, and then you will get 9 is the answer. So then you know, I mean, how many bits you need to use for the row decoder to design this size of RAM. So it is 9 bit. Then how many for the column? So the rest, right? So 15 just minus by 9, then you get 6. Right? So this is the important things that you need to know. Okay, then what else? All right, okay, this is another way of constructing a memory, right? Okay, let's say, I mean, you want to use 64K times 8 RAM memory. So there's a memory chip, right? So this is your memory chip. So the size is fixed, right? But for your design, you need to use 256K times by 8. But you have the chip for 64K times 8. So that's why if you look into your RAM, right, if you buy RAM, you will see there's a multiple number of chip on your RAM. You can try to look on your RAM, then you can see there's a multiple number of chip on your RAM, because they're using multiple number of RAM chip to construct a certain number size of memory. Right, so for in this case, to construct 256K, you can use 64K, 464K memory chip. All right, so how we can do the design? All right, so okay, basically you know, right? So how to construct 256? You know that you just divide it. Right, 256 you divide by 64, then you know the answer will be 4. Right, so that means you need to have 4. But then use, I mean, if 64K, right? I mean, if you use the calculator, so let's say you use 64K, 64K, 1, 2, 3. So look in binary, so you need to have at least 12 bits. But if you using 256K, then you need to have 14 bits, right? So 4, 8, 12, sorry, 4, 8, 12, 16, 18. Sorry, when you use 64, you need to use 1, 2, 3. Oh yeah, 64, you need to use 16 bits. When you are using 256, then you need to use 18 bits. Right? So there are additional of 2 bits here. Okay, then how you can do the design? All right, so you can attach it like this. So 64K and then 4 set of 64K memories, and here is your input data connected to the same line, and here is your address line. Okay, you see here, right? So that's the important to know the difference of the address number. So you know to construct 64-bit, you need to have 16-bit, right? So here, that's why you see the size here is 16-bit. And then the different there is 2-bit. So we use the different, so this is going to be your MSB, most significant bit, right? So this is the highest bit number. So the highest bit number will be sent to the 224 decoder. Okay, let's say, you know, the number will start from 000, right? So 00000. Let's see how many bits. 1, 2, 3, 4, 1, 2, 3, 4. Okay, let's say 1, 2, 3, 4, 12, 1, 2, 3, 4, 16. Okay, 1, 2, 3, 4. We're gonna start with this. As it increment, right? So increment 1 until it, then it start to increment here, 0, 1. When it start to go here, when it start to, I mean, for example, when it is 0, 0, right? When it's 0, 0, so it will always choose the memory here. Right, so all the data will be stored from here. Then when you keep on increment, then it becomes 0, 1 here. So when it becomes 0, 1, it start to go and access memory number 2. All right, so this is going to be the memory number 2. Then as you keep on increasing the address, right, so it become 1, 0, then it goes into chip number 3 here. Then finally it goes to chip number 3. All right, so this is how the address being divided. So when bit 17 and 16 is 0, so the first RAM here will be activated. So the address coverage from here, I mean for here, is from 0 to 65,000. Right, so any address within this range will go here. And then the second range from 65,000 to 151,000 will go to the second chip here. And then the third one will go to the third chip, and the fourth one will go to the fourth chip. Alright, so I think this is almost the same example. You guys can try to figure out on this. Alright, okay, I think I'll cover everything about the main memory. Any question regarding the memory, guys, before I go into the assignment discussion?
No, no, doctor.
No, doctor.
Okay. Alright, so no, then which part is the assignment? Okay, guys, I'm not really sure which one that really confusing you guys for assignment. I think better I'm answering your question so that I know which part that you don't understand about the counter. Sorry, about the assignment one. Okay, guys, faster. Yeah, I think some of you guys are texting me regarding the assignment, right? Yeah, and then some of you guys suggest that I discuss it in the lecture. How is the coding and its function, and how is works for cascading method? Okay, all right. So I answer Kamel question first. Okay, how's the coding, right? So I think the coding is something that you have to find out. But let me give you guys some hint on the algorithm. All right. So what is cascading counter? All right. So cascading counter is you are connecting two counter. All right. So the point that we want to control is we want to enable the point that we're going to enable this counter here. So the assignment that I'm giving you guys is that based on your I think the last four digit of your number, right? Your metric number. Okay, so I'm giving you example 4127. So why 4127? I mean, this is just my ID when I did my undergraduate, right? So I still remember it. So 4127. Okay, so let's say your last four digit of your ID is 4127. So you do the counter for 0 until 4127. So here, this part, you will count, right? So from 0 until 4127. When you reach 4127, then the counter here will be activated and count as 1, right? After 4127. And then there's you repeat again. So start from 0 until 4127, then you get another high. All right. So okay, how to do it in counter? So you have the basic counter code, right? So you set a point to detect the number here, right? So you have the counter, so you count it. So you have the equation. If the number is equal to 4127, then output. Let's say output high. Output high. So this output high will be sent to another counter, right? So by having high here, then it's gonna be connected to another counter, lah. Right? So this counter will start to count from 0. So this will be input, right? So this output will be input to the another counter as a clock, which will trigger, right? So when it's high, then the counter will start to count 1. And then another high counter is 2. Alright? So that is cascading counter. For the coding part, right? So the exercise is for you guys to learn how to work in coding, right? So that's what I'm telling you guys. You know, I'm the way how programmer works is that we don't code from 0. we do the Google search, right? So we'll do the Google search. The first one, you need to know what to Google, right? So the keyword is cascading counter. If you cannot find cascading counter, find counter, right? So then you find the code. I mean, find the simplest example code that you can find, right? The second step is that to understand the code. So that's the thing that I want you guys to do. I don't want you guys to just copy from your friend. But copying without understanding, that's the problem. Right? So that's why there's a portion for the explanation. Right? So that's how we're gonna judge your understanding in the assignment one. But if you guys are copying the explanation from your friend too, then we're gonna deduct the marks because you don't put any effort. Whoever share the answer will get less mark. Whoever copy the answer will also get less mark. So better not to share your answer with your friends. Right? So the explanation whatsoever, let your friends do by themselves, let them learn so that at least they get something out of this course. Right? So that's the thing. So first you need to know what to Google, then Google, find it, try to understand it, then try to do some changes. When you are able to understand it, then of course you know which part to change in the code, right? If you don't know, then go and seek for help. Not try to find somebody or try to ask the lecturer or something like that, right? So I mean that's how you guys need to work on your assignment. Right, so it must become from 0 till it reach our last 4-digit matrix number too large. Okay, that's what I'm telling you guys. So let me take the empty slide. Okay, the hint here, I'm asking you to use higher frequency, right? So if you guys are using 50 megahertz and it's not enough, then change to higher frequency, 100, 200 megahertz, which can be done, right? So don't worry about it. It can be done. This simulation tool, I mean, has been used for, numerous numbers of years, and people has a lot of work around it, right? So you just change the frequency. Why change the frequency? Right? So let's say 50 megahertz in 1 second, right? So let's say this is 1 second. So let's say you have just 4 tick, right? So when you are using higher frequency, you get more clock tick within the same period of time. So that's why using higher number of frequency, right, to simulate larger number. All right. Any other question, guys?
Doctor, the first counter will count from 0 till your matric to the last 4 digit in your matric number. And the
Yes.
second counter should count from what to what?
The second one doesn't matter. It's just counting. I mean, as long if you can count, the second counter can count until 2, 3, it should be okay. So I just want to see that part, right?
Okay, so the first counter is not it should be set to count from the first from 0 to last 4 digits, and then the tick will be 1, and then it will count again.
Yes, correct.
Okay, thank you.
All right, welcome.
So
Okay.
saya kurang faham yang soalan Abdullah tu. Macam mana maksudnya kita coding ni dia akan kira pada contoh kan matrik saya 0971.
Ah,
Dia akan start pada 0 sampai 971 baru dia kira 1 ke ataupun macam mana?
betul lah. So start kosong
Okay.
sebenarnya. First counter kan. So this is your first counter. Then
So bila
second.
dikira balik 0 sampai 971 second counter lah.
Yup. So ni baru satu. Last one. after it reach 4127, is the output will always be high? No, cannot. Because your output here need to look as a clock, because this is another counter. So the input of your counter need to be clock, right? It need to be look like clock. So if just one, it's not clock, right? So you need to make the output look like a clock. So go high, go down back. Go high, go down back, right? So that this counter will activate it. All right, guys. Okay, good. Any more questions, guys? Coding
No,
for
doctor.
counter to, coding for counter to look like clock. Coding for counter to look like clock. I don't understand your question, Koyu. Coding for counter to look like clock. Oh yeah, coding for counter to, yeah. No, it's not a. It's not. It's a counter. Counter to is a counter. So the input for a counter need to be clock, right? If we use 200 megahertz, will it be 4012 milliseconds? I don't understand the question in Nakib. What do you mean by this? If you use 200 megahertz, it will be 4012 milliseconds. How do you do the calculation? I don't understand it. Okay, maksudnya after zero, the counter will be zero. Then the next of the counter will be 1. And no, yeah, of course, it's starting with 0, right? So after you completed 0 to 917, it will go to 1 lah. Then 1, right? So go another cycle, yeah, correct. Then go another cycle, 0 to 971 again, it will be 2. Then 0 to 917 again, it will be 3. Alright, Hidayah. But simulation only like clock. Simulation only like clock. Okay. Again, Koyum, don't understand. What do you mean? Simulation only like clock. We can use Malay, guys. If you guys cannot express it in English, just use Malay. If you, Nakib, mana Nakib? Ni apa soalan? I don't understand. 200 megahertz will it be 4012? Okay, guys, cepat. If you want clarification on the question, please clarify your question so that I can answer it properly. If you guys have any more question on assignment 1, maksudnya clock tick. Yeah, of course. So it will be looking like a clock tick, but it's not. Okay, example. Okay, so let's say, let's say this is counter 1. Counter 1. Okay, the input to counter 1 ni clock lah, which is the clock that you set in your simulation. So this clock ni look very nice lah because it is a normal clock. Right, so then you have the second one. This is your counter 2. Counter 2. Okay. Here, of course, the output will not look like a normal clock lah. So it just high kejap, then it go down. Right, so you count until whatever your 4-digit metric number, then go high again, then go low. Go high, go low. It look like this. Not a, like not a doesn't look like a normal clock right here. Right, so it's gonna, but it should tick like a clock. Okay, Haris, sir, do we just include coding, result, and explanation? Yes. I mean, this is assignment, right? You don't need to do like report, introduction, whatsoever. So the most important thing I want is the coding, the result, and then in the coding, I need comments on the coding. Right, so let's say this is your coding, right? Include whatsoever, include coding. So comment here, explain what this line mean, right? Comment what this line mean, right? So that I know, okay, you guys really know what is the meaning of the code. Do this thing on your own. This one don't have to copy lah, right? So but still want to copy, you have to deduct marks, right? Then explanation, right? Explain, right? So how this thing function, basic. So just to portray, to let me know that you understand it, right? So that's the main goal. Right? You have to prove to me that you understand what you are doing. You are not copying from anywhere without understanding it. Okay. Does the time period matter in the VWF, or we just need to make sure the second counter be 1? Yep. As long as I can see the second counter is ticking and then the first counter is starting to count again, right? So it should be good enough. Do we include the RTL viewer? You don't have to include the RTL viewer. RTL viewer is just for you guys, to know it and maybe to debug your circuit. About high frequency and frequency. All right, so I explain again, all right? So frequency, right? So frequency. So what is frequency? Frequency is equal to F is equal to 1 over T, time period. So as the times go low, the frequency will go high, right? So here in this case, okay, let's say you are using 50 megahertz, right? So 50 megahertz. So let's say within, let's say this is 1 microsecond, right? 1 microsecond. So you might have, this is just for example, right? 3 ticks. So as you use higher frequency, let's say you're using 100 megahertz, right? Within 1 millisecond, you can have double the number. 3, 4, 5, 6. Right, so you have more tick here. So when you have more tick, you have more numbers, 0, 1, 2, 3, 4, right? So as you go high, the frequency, you will see more numbers, right? So that's what I mean by using more frequency. So do you want us to add comment in the coding or can put it in our Word file? I want you guys to paste your coding in the assignment with the comment. If we use period 20 nanosecond is equal to 50 megahertz, 1 millisecond is equal to 1 kilohertz. Yeah, so 1 kilohertz and 50 megahertz. Which one is higher? Of course, 50 megahertz, right? So use higher than more 50. Right? Let's say 100. If not enough, use 200. If not enough, keep on increasing. Right? So yeah, of course, you vary it based on time. Right? Do the calculation then. So 1 over, how to get the F is equal to 1 over T, right? Okay, guys, any more question? Okay, all right. So I assume that you guys have no more question. All right. So, but if you do have question, please, just let me know. Then, if I can help, then I will help you guys. So I'm hoping that so this session, yeah, I'm gonna upload this session. So not necessarily count in no no no, not necessarily count in millisecond. No, we don't care about the time. We care about the output now, right? So we forget about the time whatsoever. The only thing that we concern here is the waveform. As long as you can show the waveform, the whole part of the waveform to me, it's okay. What time that you use doesn't matter, right? Okay, all right. So if no more question, then I will end the session here. Thank you so much. Then I'm hoping you guys try to work on the assignment, try to complete it, so that do on your own. At least you learn something, out of it. And then I'm wishing you guys to have a wonderful weekend, right? So see you guys next week. Thank you.
Doktor.
Yeah.
Contohlah kan, kan kita guna nombor metrik belakang tu kan 4.
Okay.
Lepas tu, dekat waveform tu kan input kan. Kiranya kena ada 4 input ke. Contoh, contoh Q tu dia bawa masuk nombor 4 dulu. Contoh. Lepas tu, yang ke macam ikut binary tu. 4, 0, 1, 1, macam 4 ke binary lah. Faham tak? Faham tak, Doktor?
Tak faham. Sekali lagi.
Maksudnya dekat waveform tu kan,
Okay.
kena ada contoh kan ada 4 kena masuk untuk input. Jadi kena ada 4 input waveform. Maksudnya ada Q, B, ni contoh lah Q, B, A, macam tu lah dekat waveform. Contoh Q tu bawa masuk nombor 4 dulu ataupun dalam Q tu akan bawa masuk 4027 contoh.
Oh, sekejap. Maksud kamu macam mana? Saya tak faham. Boleh lukis tak? Share screen jap. Boleh? Baik, Azwani. Awak senyap.
Siapa dah saya lukis, saya buat dekat WhatsApp lah sebab saya guna phone. Tak boleh nak ni.
Nanti lukis buat kat WhatsApp nanti tanya.
Okay.
Alright. Okay. Okay guys, thank you so much. Bye.
Thank you, sir.
Thank you,
Thank
Doktor. Assalamualaikum.
Thank you, Doktor.